So what's important to notice here on this problem is this looks a lot like our double angle identity for cosine. Well, it's not quite, but there's a rule we can use where we flip this around the negative sign, okay? But those two aren't equivalent. When we do this and we flip it around, a minus sign, we have to put a minus out in front of the parentheses. If we see this is a similar thing. So this looks a nut like one of our other cosine double angle identities. So let's flip it around. Cosine squared theta minus 1, but again, we have to put our negative out in front. And now we can make the appropriate substitution. We have negative cosine 2 theta equals negative cosine 2 theta. Hello, in this video, we're not doing an identity, but we're going to work on simplifying. So let's start by distributing the cosine. So the cosine cubed. And now we can start simplifying. We take this out with 3 of these, and we take this out with 3 of these. Next, I'm going to go ahead and give a common denominator with this. Anytime I've got a fraction with a non-fraction, it's good to get the common denominator. So we get, now, this is the difference of squares. Here, this would be 1, so it effectively falls away. And then here we've got the double angle identity for cosine, which would be cosine 2x minus 1 over cosine x. And if you see another way to simplify this, let me know in the comment section. I don't, so I'm going to say we are done. I think this is a really famous identity because I see it around a lot when I'm looking at different resources for my pre-calculus class. We're obviously going to work with the left-hand side, so we're going to take this and we're going to expand and distribute. So that would give us sine squared x plus cosine squared x minus 2 sine x times cosine x. I'm going to do the same here. I'm going to write it below it, so that's sine squared x. Remember, we'll put a plus here to indicate that it carries over, plus cosine squared x plus 2 sine x cosine x. Well, if we notice, we have Pythagorean identity here and here, so that would be 1 plus 1, and then these two would just cancel out. So we get 2, which is what we have on the right-hand side. This is one of my all-time favorite trig identities because if you know the cosine double angle identity, you know it's equal to cosine squared x minus sine squared x. How could it also be equal to cosine fourth x minus sine fourth x? Well, here we have a difference of 2 squares. So I'm going to write that as cosine squared x minus sine squared x. Make sure I put that in parentheses, times the cosine squared x plus sine squared x, and I apologize, I forgot to put that I'm dealing with the left-hand side. Now, we have our Pythagorean identity here. That's 1, so that effectively cancels out, and now we have cosine squared x minus sine squared x is equal to cosine 2x, and we're just stating the double angle identity, but if you wanted to take it a step further, you could go ahead and say cosine 2x equals cosine 2x, and then you're done. And you have your identity. Hello there. In this video, I want to tackle and see if we can come up with a triple angle identity for sine. So the trick to do this is to write it as sine of 2x plus x. Then we can use our sine addition identity. That'd be, okay, great. We're going to use our double angle identities for sine and cosines. Now, these two terms can combine, and then we can distribute this. These two terms are the same because multiplication is commutative, and so we have 3 of them. So that's 3 sine x times cosine squared x minus sine cubed x. Now, if you wanted to leave it like this, you could, but notice we have a common factor of sine we could take out. So sine x times 3 cosine squared x minus sine squared x, and we're done. But again, which one of these you take is really up to your preference. Hello there. So we're done. In this one, we've got a pretty hefty looking identity. So let's go ahead and deal with the left-hand side first, okay? So here we have the identity for the double angle tangent. And then here we have a double angle identity for cosine. But I'm going to leave it as 1 over cosine 2x, because now I'm going to write tangent in terms of sine 2x plus 1. And now I can combine them into a single fraction. The reason why I'm going to do that is I'm going to stop here, and now I'm going to tackle the right-hand side. Now, we multiply the bottom and the top. So just to note, that's cosine x plus sine x. And in the bottom, we have a difference of 2 squares. So that's okay. So we're multiplying the top by itself. So that would give us, okay, here we have 1. Here we have the double angle cosine. And here we have the double angle sine. And we're done with So let's go ahead and see if we can add to our triple angle identity for sine and do one for cosine. So we take the same approach, use the sum formula for cosine. So that will be, once again, we'll use our double angle identities for sine and cosine. So we'll go ahead and distribute. We get, now here we have the sines to combine. We get, with the sine formula, we have 2 of the same thing. Well, actually we have 3 of the same thing, but this time both with minuses. Okay, or like we did with sine, you could factor out a cosine, and you get cosine squared x minus 3 sine squared x, and maybe that looks a little bit nicer to you. Either way, we are done with this identity.